In this video, I'm going to cover mill part 2. So I'll put the drawing on the screen right here. This part is really similar to the previous part in that the alignment will be the same. If you notice, all the dimensions still come from the bottom left corner, but we've got some difficulties to tackle in the dimensioning scheme of this part that's going to require some new concepts, which I'm going to cover in this video. So, the new concepts, we're going to use something called recall, which uses features you already have to develop theoretical features. So we'll get more into detail later in the video. We're going to use a 3D line to establish a line between these holes so that we can use the angle between features feature to report the angle as on the drawing, that 30-degree angle. Then we'll change the strategy in our probing for the top plane, which I'm going to talk about right now. So the alignment, really similar. I'm going to go ahead and get these two 2D lines on the sides of the part to establish our X and Y, and then I'll slow it down to do the plane. So I've got my program saved as mill part 2, demo 2. It's totally blank. So when I go and take these features, so it'll, the first thing that'll be here. So I'm going to drive over. I'll take the X first. So this is going to establish our, dimensions in X, right? We typically think of, we're looking at the machine, left and right is X, front and back is Y, up and down is Z. So 2D line, I'm going to name this left side of the part, right? That way I can keep track of it a little bit better. Other than that, I don't need any more information. I'm going to hit OK. I'll go to the bottom of the part, same idea, take 2 points. I'll name this bottom side of the part. Again, it doesn't really matter what you name them as long as it makes sense, generally. I mean, it's got to make sense to you. Hopefully it makes sense to other people as well. So I hit OK. Got those 2 features. I'm doing it slightly different than I did before. You can do the alignment both ways. You can open up the alignment and populate the features as you go, or you can put the features in first and then choose them from the alignment, which I'll show you in 1 second. So now I'm going to move the probe up, and I'm going to get this plane. Now this is where we're going to change the strategy. Remember what I said before in the previous part, when you take points, when you save that feature, it's going to revert to scanning by default, unless you go in and change the defaults. Now you can do that too, but these machines right here will revert to scanning. We're going to change that back to points. The reason, you can see here, if you put a point here, put a point over here, it's kind of difficult to get in a straight line without running over a hole. It's definitely possible, you could do it, and you could take more points to avoid the holes. But just for practice, I want to switch it over to points. So let me take a point on each corner. And I'll take 1 point in the middle of the part, okay? I'll name this top plane. And now I want to show you real quick, if you go to strategy, it says probing points. And that is a quirk of Calypso. You think it's probing points, right? You close this. Now if we do close it, hit OK here, and then open it back up and open strategy, it's changed to a polyline. Why? I don't know. But I do know how to change it, okay? So we're going to click on this polyline, and then we're going to click here. I'll hover over this for you. Single points to auto path switch. Just make sure you have polyline selected. Click here, convert selected features to polyline, hit yes. Okay, that's all there is to it, to change the strategy. If we want to change it back, we select them all and then do the same thing. Okay, so I'll select all of these probing points, hit this, convert it back to a polyline. Okay, and then this opens up. There's layers to this, right? You can get even more detailed and detailed. For now, we're not going to worry about the particulars of the strategy. So Hit this again, change it back to points, which is what we were looking for. Hit OK, and I'll hit OK. So that feature will, the probe will go down and take to 5 points. It won't drag it around. So these are the 3 features we need for our alignment. Let's go ahead and knock out the alignment. We're going to go to the Measurements tab, hit Base Start Alignment, hit OK with this dialog. Spatial rotation will be our top plane. Hit OK in this dialog. Planar rotation, I'm going to choose the x-axis, but you could choose the other 2D line. Hit OK. The X origin, I want to be that left side, okay? So X is left to right. I'll choose that left side of the part. Y origin, this right here, the bottom side of the part will control that front and back, okay? So select bottom side, hit OK, and then Z origin will be that top plane. We want our Z to be 0 on that top plane, so when we're probing holes, it'll be negative, which we'll talk about in just a minute. Hit top plane, hit OK, and now our alignment's good. You can see our coordinate system is right on that top left corner of the part, just like it should be. I'm gonna hit OK. So we're happy with the alignment. Go through the clearance planes real quick. It'll be the same as the previous video. We'll do Z plus first. I'll get on top of these clamps. We'll do X plus, Y plus, X minus, and again, I'm just getting to the other side of the clamps, and then Y minus, okay? And that's all we need. If I zoom out on my computer screen here, you can see it's got our clearance plane boxed around the part, okay? So I'll hit OK with that. And I'm gonna answer no to this dialog. I'm not gonna update the clearance planes. So I wanna show you one trick real quick. If you wanted to check that top plane before you get further into your programming, we'll go to the Features tab. We're gonna right-click top plane, and we're gonna select Execute. Before I do that, I'm just gonna move my probe above the part so it doesn't smash into it. Hit Execute, and again, it asks you to move it to a clearer position. We just did, and I'm gonna hit OK. And the machine will go in and execute that one feature. Now, especially when you're just learning how to do this is a great way to check your program as you go, so you don't have 50 features and you run the program, there's an error, and you can't figure out what it is, okay? So you can check every feature as you make the feature. So we're happy with that. Now we want to go in and establish these holes. So I'm only going to do one of the patterns of holes. I'll do the top pattern. So I'm going to get the center hole, and then I'm going to start at the 12 o'clock and then go to the 3 o'clock holes, okay? So I'm gonna drive down into this hole. I'm gonna shoot for halfway, but it's tough to tell. We can change it later where it actually probes. We're gonna make them all the same. So I like the F11 macro. I hit F11, hit return, and then it's gonna take those 4 points automatically, okay? When it's done, I hit OK on the strategy. I'm cool with probing points for now. Now for the center hole, this one we're going to want to output the X and the Y coordinate. It's the only hole in this pattern that we're going to do that. The other holes, and I'll put the drawings back up for a second, the other holes are not dimensioned with X, Y coordinates. They've got polar coordinates. So they've got that angle and that distance from the center and that diameter bolt circle. Those are going to be dimensioned differently. So I'll report the X and the Y. The tolerance on these is 5 thousandths, so I'll remember to punch that in so we don't have to do it later. 5 thousandths all around, and then our diameter is going to have a tolerance of +8 - 2, okay? And now, since we're not working from a CAD model, we've got to input the nominals from the drawing into the computer. So if we notice right here, the tolerance X is 0.494. That's what the computer actually measured. That's not what the drawing says. So we want to punch in 0.5 here, okay? Same idea with Y. We want to have it 1.75. And then for the diameter, we want it to be 1/4 inch, 0.25. So the difference between the nominal and what the computer measured is the variation, right? And that's exactly what we're looking for. So we're all good with this. I'm gonna hit OK. I can go to my characteristics tab and check and see if we're good with our outputs. Now for now, it really doesn't matter if it's in or out of tolerance. We're just writing the program, okay? So this red indicates that it's out of tolerance. No big deal for now. Unless you made this part, then you're in trouble. So we'll go to the features tab. Now we're gonna go to the next hole, and I'll do all 4 of these in pretty quick succession. F11, hit return. For the next 4, all we're gonna output is the diameter. So hit that diameter checkbox, make sure your tolerance is good, and then hit that 0.250 for the nominal. And remember, in the tolerance classes, set it to last input so you don't have to enter every single tolerance every single time, okay? So we're happy with that, and then I'll go through to the next one. So again, I'm gonna report the diameter, I'm gonna punch in the nominal, tolerance is good, I'm gonna hit OK. Okay, so we've got our 5 holes, we got the diameters for all of them reported. Now we need to figure out what that angle is and what that bolt circle diameter is. So what we're gonna use is something called a 3D line. So the 3D line is gonna go from the center of the center hole to each of the centers of the satellite holes. So we're gonna need 4 3D lines, and those are the features we're gonna measure the angle with. Now, we've gotta use something called a recall to get the 3D line. So let me go ahead and show you. I'll go to Features, up here in the Features tab, 3D line, click it. As of right now, the 3D line has no information to go off of when we're gonna punch it in. So I'll double click 3D line 1. I'm gonna go to this middle drop down, and I'm gonna select recall. And now I'm gonna hit Control, I'm gonna select circle 1 and circle 2. So what it's doing here is figuring out where the center of those circles is, and it's gonna connect that line to those 2 centers, right? So circle 1, hit Control, select both of them at the same time. You can see them lit up on the computer screen in the work area, and hit OK. And we're all good here, hit OK. Now, there's a tricky thing with 3D lines. So they're 3D, so they're in X, Y, and Z. The problem is when we probe these holes, because we just probed a circle, if we probed one way down and then one up way higher, that 3D line will connect the center of those 2 circles. Now that can be a problem because if they're way off, it'll make the 3D line longer, right? It'll be tilted in space. What we want is for all of those 3D lines to be level, so when we measure angles or anything else we might measure, we're working from a level playing field. There's more than one way to do it, okay? The way I'm gonna show you, we're gonna adjust the probing depth of each of those circles so that we know each of those 3D lines is flat. So, how do we do it? Let's go to circle 1, I'm gonna double click. We're gonna go to the Z, the nominal, and we're gonna change it to 0.15. And then if you watch the computer screen, I'll zoom in here, when I hit enter, that circle moves, right? So it's just adjusting the probing depth. So we're gonna go through and make all 5 circles negative 0.15 inches. And it's negative because Z0 is this top plane. So anything below this top plane is going to be negative, okay? So I'm going to hit OK, go to circle 2, same idea. If you notice, the Z on this one is a 1/4 inch, so when I probed, I went down further. It's really difficult to control exactly where you probe. 0.15, hit enter, and you'll see that circle move up. Okay, so I went through all 5, made them all level. They all probe at negative 0.15. Now we know all those 3D lines are going to be level, so it'll give us a better measurement. So now I'll go through, I'll do the next 3D line. I'll go to the features, 3D line, double click, options, recall, circle 1, and then now we want circle 3. Hit OK, and I'm going to hit OK. Right. So features, again, 3D line, double click, options, recall, now go to circle 1, circle 4. And it doesn't hurt to take a look at the screen and make sure you got the right thing selected. Hit OK, hit OK. Features, 3D line, recall, circle 1, and circle 5. We're going to hit OK. All right. So those are 4 3D lines. Now we can measure the angle between those features. So we're going to go to the Form and Location tab, and we're going to choose the very last thing. So nice and easy to remember. Angle between features. Click, and you can double click angle between features 1. And this works just how you think it does. It's kind of like alignment. We're going to click in that gray box, then we're going to select the features from a list. Gray box, we're going to select 3D line 1. You can see it lit up. Hit OK. Feature 2, select 3D line 2. And now we can see them lit up on the screen here. You can see that angle developing. I'm going to hit OK. And the actual is right down here, 30 degrees, give or take a little bit. That's what we're looking for. That's what's basically on the drawing. Now, like any other output, we're going to adjust the nominal. We're going to make this 30 degrees. And then on the drawing, it indicates it's plus or minus 2 degrees. Okay, so I'm going to punch that in. Upper tolerance 2, lower tolerance -2. Remember to keep that negative sign in your lower tolerance for any tolerance in Calypso. So I'll hit OK. I'm going to do the same thing for the next features. So Form and Location, angle between features, double click. Feature 1, we're going to select 3D line 2, 3D line 2, hit OK. And then 3D line 3, hit OK. We're going to punch in the nominal. If you have a last input selected up here, it's going to remember that 2 degrees from the previous feature. So actual 29, hit OK. And then the last one, angle between features, double click. Feature 1, 3D line 3, hit OK. Feature 2, 3D line 4, hit OK. Punch in the nominal. Tolerance is good, +2, -2, and I'm going to hit OK. All right? So that covers that part of the drawing. We got those angles squared away. Now we've got to cover that bolt circle. Now, what I'm going to do is measure between the center of the center hole to each of the outside holes. So we'll have 4 measurements. You can also measure the bolt circle around, but when you do that, and you could use a recall to do the bolt circle, you're really just taking the average of where those holes are. So if one is like way off, your bolt circle will be bad, and you'll see that on the drawing. It'll report bolt circle bad, but you won't know which hole it was, right? So when we do them individually, we can find out exactly which hole is the offender if one of them's off, okay? So how do we do that? We're gonna go to size, distance, and we're gonna use polar 2D to measure the distance from the center of the center hole to the center of each satellite. Polar 2D, double click, feature 1, circle 1, feature 2, circle 2, okay? And then our primary datum, will be that top plane. So what it's doing, it needs that datum to lay flat on, okay? So the distance, 0.876, that makes sense to me. We're gonna take that bullet circle diameter, cut it in half, and then we're gonna cut the tolerance in half as well. So on the nominal, I'll do 0.875. The tolerance on that bolt circle is plus or minus 10 thousandths. So we're gonna make it plus or minus 5 thousandths for each of these 4 measurements, okay? So I'll hit okay, we're all good there. 2D polar distance, and I'll do that again for each of the holes. So size, distance, polar 2D, double click, feature 1, circle 1, feature 2, circle 3, okay? Hit OK, primary datum is going to be our top plane. Got to remember to punch in our nominal, and remember to punch in our tolerance. And it looks like I made a mistake on the upper tolerance of the previous one. So I'm going to hit OK here. I'm going to open this back up, and I did make a mistake. Let me put 5 thousandths there, save, so that first polar distance is good after all, right? So I'll do the next 2 and speed up through this. Okay, so those are our polars. That's going to give us the answer to the question, are these holes within tolerance? And let me put an image up real quick. This is what the tolerance zone for a plus minus dimension bolt circle looks like. It's kind of like a crescent shape, right? If it was a positional tolerance, it would just be round. But when we have the plus minus, we've got the wedge from the angle, then we've got the bolt circle that gives us some tolerance there too. So each of these holes, got to look at 2 things, 2 outputs. You got to look at the polar distance, then you got to look at the angle between features to figure out if the holes are within tolerance with the output on Calypso. So the last thing I'll do is the bolt circle. We'll output it because people are going to ask, if you check this part, what's the bolt circle? It's on the drawing, why isn't it here? Why'd you do something different? I want to see what the bolt circle is, so let's do it. I'm going to go to features, going to select circle. When you're doing a recall, you have to make the feature, okay? So I selected it from the feature list, double click circle 6. I'm gonna go to options, recall, and I wanna select all of the satellite circles, circle 2 through 5. So 2, shift through 5, and hit OK. You can see it on the screen there. It develops a theoretical feature that goes through the center of all of those circles. If you notice, the nominal is grayed out. That's because it's a theoretical feature that relies on other features to determine how big it is. So if you use CAD a lot, it's kind of like the difference between a driven and a driving dimension. So theoretical features are driven by real features on the part. But we could go ahead and report that diameter, and we can give it a tolerance. So it says plus or minus 10 thousandths on the drawing. I'll report it just like that. Now again, if the bolt circle is out of tolerance, it doesn't really tell you a lot, right? You don't know which hole is out of tolerance, but you put it there anyway. So that's it for writing the program. Let's go ahead and run it just for fun. So I'm going to come down here to run. I want to check clear existing results. I'm going to go to the name of the program for my base alignment. I'll get my hand on the speed dial so the machine doesn't go wild on me. I'm going to hit start. And I'll keep my hand on the speed dial as it goes through features. Now again, when it's scanning, you can let it run at full speed. When it gets near to the end of its scan, you want to slow it down if you're unsure. And so when it's going between features is when it's most likely to crash, okay? So I'm gonna let it speed up because it's just scanning. Next, it'll go to the top plane, and then it'll check those holes. Okay, so that's it. I'll show the PyWeb report on the screen. I'll zoom in here a little bit. This part checked out. So again, it's better to name the feature something more specific than I did, so you can go through the report and know what's what. But that's basically how to write the program for Mill Part 2. I talked in the beginning about some of the features we use, so I won't repeat it. If you enjoyed the video, please like and subscribe, and check out the channel for more videos like this coming soon.